So we are ready to discuss what happened in the past 3 years in the work package T3, Modeling Emerging Contaminants Model Application. So modeling has become of great importance in the field of water resources investigation. What we have to keep in mind, however, is that models are simplifications of a real-world system. So all of them are wrong, but some of them can be useful. But useful for what? What are the main objectives, therefore, of a model? So hydrological and solute transport models are important to improve the understanding of the system, so to get a little bit more information about the dynamic, the fate and transport of the contaminants in our system, to predict future scenarios in order to evaluate, for example, if a contaminant is going to hit a sensitive source of water. And to improve also water management strategies, and to compare also among different water management strategies before implementing them. What are the expected outcomes of the implementation of new water management strategies for our system? Modeling emerging contaminants, and in particular pharmaceuticals and personal care products, is still challenging in comparison to modeling other contaminants of concerns like nutrients or like hydrocarbons, because a standardized approach is not well established. In fact, PPCPs, so pharmaceuticals and personal care products, are not commonly studied and monitored. As we say, they are still emerging contaminants, so they are new contaminants for which we are still trying to understand and to grasp some of their properties when they enter in the environment. The second issue is that PPCPs are usually detected at low concentrations, and therefore there is a higher uncertainty in the measured data in comparison to other compounds for which we have decades of experience in measuring them. And finally, most of the PPCPs are scarcely regulated in the Water Framework Directive. Therefore, there is not much experience because there was not a driving force that pushed, let's say, the community in modeling these contaminants, due to the fact that it is still quite unknown what is their effect on human health, and at least in most cases it is not regulated. The activities that we plan to do in Work Package 3 are related to a review of the modeling activities in water management system in the countries involved in the boDEREC-CE project, to identify the needs, elaborate solution, and develop a capacity building strategy related to modeling of PPCP. And finally, in our study areas, we aimed at having some model applications in order to see how in different situations the problem of modeling PPCPs can be tackled. The outputs that we wanted to achieve were the development of a model-based decision-making tool for emerging contaminants, Modprocon, and I invite you all to attend the webinar related to Modprocon. We also developed training courses related to Modprocon and in general to modeling pharmaceuticals and personal care products as massive open online courses that are now available, for example, on YouTube. And then finally showcasing applications in 7 countries for Modprocon, so to see how this tool can be applied in our study areas. And we aimed at covering our 3 clusters, which means water resources deriving from karst water system, from surface water system, including riverbank filtration, and from groundwater aquifers. The results, considering the review, is that there is a general use of models in all countries but this is quite scattered, both in terms of purposes for which models are used, as well as in terms of tools. However, there is a general recognition about the importance of modeling. Nonetheless, the fact that it is acknowledged the importance of modeling does not necessarily mean that several stakeholders and several infrastructures have capabilities and know-how to implement complex models like solute transport model related to pharmaceutical and personal care product. Therefore, our conclusion is that there will be the need of strengthen the capacity building in order to be able to apply this tool, which is modeling, to water management problems. The second outcome of our project was the development of Modprocon. Modprocon is a model-based decision-making tool for PPCP, and we related to it a massive open access course. So the idea behind Modprocon is to perform two kinds of analysis. The first analysis is more related to the chemical properties of the compounds. According to the sorbability, for example, of the compound, its capability of being volatilized, the degradation that the compound may undergo in the system, the solubility of the compound. We want to help the stakeholders to know whether or not they may expect a contaminant of concern to be present in the water resources. Therefore, we implemented the decision tree that was developed by the project partner BOCU into a graphical user interface, such that it can help the stakeholders knowing if the probability to detect a pharmaceutical or personal care product in water is likely, very likely, unlikely, or very unlikely. In case it is likely or very likely, we suggest the stakeholders to develop a model. As we discussed, very often our stakeholders do not have the know-how to develop in-house a model. However, they must know, or they should know, what are the required parameters, the required data in order to be able to develop a model. And therefore we help them through a data viability check that tells them whether the model can be built or if the model cannot be built. In case the model cannot be built, we try to provide some suggestions how to gather the data that are missing. And then the suggestion is to get in contact with an expert. It could be a university, a research institute, or also a company specialized in hydrological modeling that will support them in better understanding the possibility for the compound to enter the water resources that they are managing. In the MOOC, we try to give a brief training about the use of Modprocon through 7 tutorials and 3 explanations of the application of Modprocon. A key aspect of our work package was the hydrological model development for the pilot actions. We divided our pilot actions in different clusters. The first one is surface water, which includes also riverbank filtration. And as you can observe, the different project partners were allowed to use their typical or their expertise in modeling in order to tackle this issue. The first step was to develop flow models, so how water behaves in the system and how water flows in the system. And we can see here, for example, that in Dresden they used Modflow WHM, while, for example, in the Po River Basin they used more HEC HMS or Topkapi, for example. The same heterogeneity in models that have been used can be found also in groundwater pilot action, where water resources are derived from porous aquifers. And we can observe also in this case the variability in the tools that are used. Finally, for the karst water pilot actions, we had also two study areas. In one case, the LUCARS model was applied. In the other case, the karst model was applied. And we can see also in this case the difference in the expertise that is present in the different countries in order to tackle the problem of modeling water availability practically in our system. Even more complex is the situation for transport models. So in the first step, we try to model how much water is available in our systems and where it comes from. In the second step, we wanted also to observe what is the effect on, or what is the fate of the contaminants of PPCPs in the environment. Here we had to tackle several issues, like, for example, very low data availability in order to validate and calibrate the model. Nonetheless, we have had very nice intercomparison studies showing how different it can be the challenge of modeling PPCP in the environment. In fact, in this case, we ranged from physically based quantitative models, like the application of MT3DMS for the German pilot action of Dresden, to conceptual transport models, like our project partner in Poland, in which the model consisted more in an interpretation of the data due to the lack, for example, of enough information to develop a really physically based predictive transport model. The same situation occurred also for the other water clusters, in which we had, let's say, both situations where we had advanced numerical models, physically based models that predicted also the behavior of the contaminants in time, and models that were more focusing on the understanding of the dynamic of the system. In karst system, the situation is even more complex. Indeed, in both cases, the developed models were both of a conceptual nature. So, considering the data availability and considering the complexity of the system, the project partners aimed at better understanding, let's say, the concept, the conceptualization of the transport model, of the transport processes present in their karst systems. So the challenges that we have identified in this project are related to modeling PPCP in situation where we have a low spatial and temporal resolution of the data available. And this is a common problem in several situations due to the fact that, as we said in the beginning, measuring PPCP is something new, is something difficult, and therefore we cannot expect to have very long time series or very spatially distributed information related to the concentration of PPCP in the environment. This leads to uncertainty in model prediction, and we have uncertainties also in the physical and chemical properties of the PPCP, in particular, for example, on the biochemical decay of PPCP in the environment, which can be very different depending on the site-specific condition of the system that we want to understand. Moreover, we have identified a general uncertainty in the contaminant source identification. Even in the case of the application of physically based model, it was not always clear where the source of the PPCP could be located. In this case, we, in the framework of the project, in some situations, we have been able to use the so-called inverse modeling. So, starting from the location where we have identified the contaminant, we tried to backtrack the source of the contamination and this allowed us to estimate what could be the cause of the emission of PPCP in the environment. And as a general problem, we have identified a lack of expertise in modeling activities, in particular in transport modeling. Therefore, the big effort that has to be taken for the future in capacity building actions to train adequate personnel in order to get advantage of this very important and fundamental tool. So, concluding, the transnational review of existing country-specific framework for model application gave us fundamental information for having an overview of the actors involved in modeling activities, their goals, and their know-how. Modprocon has the goal of helping water manager and stakeholder groups in approaching the modeling of PPCP, in getting a better understanding what it means modeling and the importance of having enough data to set up predictive models. The case studies collected in boDEREC are very important and interesting in order to show the challenges that can be present in the understanding of the fate and transport of PPCP in the environment. So, thank you very much for your attention.